Okay, right now we will continue on exercise number 2. So still using the Thevenin to get this V out. Okay, so using Thevenin circuit, find V out. So the first step is actually to get RTH. So what is your RTH? So first of all, what you need to do is to disconnect load. So right now your load is actually this 50 ohm, so you need disconnect the load. And the second step is to kill all the sources. Okay, so I is equal to 0 and also V is equal to 0. So mean that your circuit will be written like this. Okay, so this is your terminal load BA. This is positive, negative, and then the voltage right now is short circuit, and then you have this 150 ohm. Okay, and then you have this resistor, which is the summation of 55 plus 20 because they are in series. Okay, so since this one is actually open circuit, so we can actually ignore this branch because there is no element here, so we can actually ignore this. So that your R equivalent is actually C from this determinant. Okay, so from this I can see that my R equivalent is actually 150 parallel with 75, which is you can calculate 150 multiplied with 75 over 150 plus 75. Okay, you should get around around 50 ohm. Okay, so this is your RTH. So I just write down here just to remember. It's 50 ohm. Next is actually to find the VTH. Okay. So VTH, you need to turn on back all the voltage and current source. So the circuit will be like this. 20 ampere. Still, this is your load terminal, which has been disconnected. Okay, this is your positive, negative. So this is your VOC or VTH. Okay, then this is your voltage source, 25 volt, and this is okay. Sorry, so this is then you can actually series it up, just add up. So this one will be 75. All right. So I can actually simplify the circuit, become like this. 20 ampere. Same. 25 volt. This is your terminal BA, which is positive, negative VOC. And this actually you can actually simplify it. 150 parallel with 75, you should get is equal to 50 ohm. Okay. So this is 50 ohm. Okay. So what next to do is actually you don't need anything. Just use a basic Ohm's law. As you can see here, this is just a single loop. A single loop. The same current, 2 ampere, will flow through 50 ohm and also the voltage source. Okay, in the counterclockwise. So meaning that this is a positive. So this is negative. So meaning that the voltage for the 50 ohm is positive 50 multiply with 2 amperes, so you should get 100 volts. Okay, so okay, sorry, 100 volts, and the VOC or equal to VTH. So VTH is actually, I can see is actually, if you look at this KVL, okay, like this KVL clockwise. Let's put a clockwise here. Okay, so sorry, my KVL is negative VOC because I put negative here, and then plus 25, and then minus 100. This is equal to 0. So I can finally got my VOC is equal to minus 75, right? Minus 75. So that is my, so this is actually my VTH. So right now I have my RTH and I have my VTH. So I can actually calculate my V out, VO, okay? So I draw my equivalent circuit. So positive, negative. So my VTH is negative, sorry, 75 volt. Okay. And my RTH is 50 ohm. Okay, and I connect with my load right now here. My load is 50 ohm, so need to calculate what is my P out here. So this is a very simple circuit, just a single loop here. Then you can use a voltage division. Okay, so V out is actually 50 over the total resistance 50 plus 50 multiplied with negative 75 volts. So you should get your V out is also is actually negative 37.5. So that's all.